My name is Wang Yue, and I'm leader of Group B No.6. Today, I'm very glad to present our group project titled Flight Daily Data Analysis and Visualization. In this project, we adopt a professional data-driven approach to analyze real flight data, explore the main cases of flight delays, and provide potential suggestions for aviation operational optimization. First of all, I'll introduce this research background and problem statement. In recent years, this global aviation industry has achieved to a strong recovery. The number of flights and passenger demand keep rising rapidly. However, frequent flight delays have become a serious problem. Flight delays not only increase operation costs for airlines, but also reduce passenger satisfaction and damage airline reputation. Traditional experience-based decision-making can no longer solve these complex operational problems. Therefore, we put forward five crucial business questions and six clear research objectives, aiming to find hidden delay patterns and provide effective improvement solutions. Next, I will introduce our dataset and analytical approach. For this research, we use the flight delay and cancellation dataset from 2019 to 2023, which is coded from cargo platforms. It contains real US flight records, including flight schedules, daily time, daily case, airline, and airport information, as well as the flight distance. Before analysis, we finished the complete data cleaning. We removed the invalid records and extreme outliers to make the data accurate and reliable. We applied five simple and potential analysis methods: comparative analysis, time series analysis, ranking visualization, correlation analysis, and operational bottleneck analysis. All data processing or visual charts are created by using Microsoft Power BI.
I will talk about the key focus that cause flight delay is based on our analysis. First, let's talk at the member. Let aircraft delay are the biggest problem with an original of 25 minutes. Current issues are second at 24 minutes. There are two international operational problems the airline can control. Other factors like the national air sentence cause less delay, only 25 minutes. Weather and security issues have even more impact. So our main conclusion is clean, international controllable focus and main reasons for delay. This menu if airline want to reduce delay, they should focus on improve our opportunity like air control situation and conclusion purpose. Now, let's talk our analysis of flight delay time partner. First, the monthly partner delay are highest in summer. June has the longest delay at 35 minutes, followed by July at 34 minutes. September is quickly with just 5 minutes on original. This shows a clean Song-Senon trend. There's the weekly partner delay peak on weekday at around 10 minutes, where Friday has the shortest delay at about 9 minutes. The main takeaway is delay follow both sing-song and weekly partner. With management that mean airline can propose better. They could run staff or plans in business summers months and on weekend to reduce delay. Okay, we look at airplane performance. There is big difference in the delay between airlines. So airline like JetBlue has long delay, with other like Asia Airline performing much better. Then the airport with same partner, some original airport, except regular ones, have much higher original delay than other. The main conclusion is clean. There is large performance gap between top and bottom airline and airport. For management, that means we need to focus more on the high-rise area. We can give a regional research and supervision to underperforming airline to business airport to help reduce delay.
Here is the fourth question: the relationship between distance and delay. From the scatter plot on the left, we can see that the data points are widely scattered, with no clear linear relationship between flight distance and average arrival delay. Although the trend line slopes slightly upward, the correlation is extremely weak and statistically insignificant. This means that the flight distance is not a major factor influencing delays. In other words, long-haul flights are not necessarily more likely to experience delays than short-haul flights. This finding challenges the common assumption that longer flights automatically lead to a higher delay risk. Instead, delays are more likely caused by operational factors such as airline efficiency, airport management, weather conditions, and ground operations. Therefore, from a management perspective, airlines should focus more on improving operational efficiency and resource coordination rather than simply avoiding long-distance routes. Come to the fifth question. How do operational factors affect delays? From this chart, we can observe that as flight volume increases, the average departure delay also tends to rise. This suggests a strong relationship between airport congestion and flight delays. In particular, mid-sized hub airports are more vulnerable when flight demand exceeds airport capacity. This can result in runway queuing, gate shortage, and ground service backlogs, which eventually create a cascading delays throughout the system. Therefore, our core conclusion is that airport congestion is one of the most critical operation bottleneck causing delays. To reduce delay efficiency, airlines and airports should optimize resource allocation, improve ground operation efficiency, and better balance flight traffic during peak period.
Hello, my name is Zhu Jingle. I will lecture on 4 and 5 chapters. Our Power BI dashboard has 3 key pieces. The first shows overall performance and is total flight, average delay, delay rate, and time trends, helping you quickly grasp operational practice. The second does segmentation analysis, ranking delays by airlines and airports, and plotting distance adjust delay to spot problem areas. The second brings root cause analysis, breaking down delay into weather, security, and airlines issues. Together, they flow clean flow. Macro overview, macro diagnose, root cause analysis, spotting real-time data-driven decisions. We propose 3 levels of recommendations. For 0 to 3 months, take immediate actions. Strengthen the aircraft turnaround. Boost peak resource. Build real-time delay monitoring and optimize flight conditions. For 3 to 12 months, make media time improvements. Optimize schedules with faster time. Enhance airport traffic flow. ring performance, benchmarking, and adjust resource dynamically. For more than 1 year, pursue long-term strategy, adopt productive analysis, strengthen mutual pattern, collaboration, accelerate digital transformation, and invest in infrastructure. These steps catalyze and left performance sustainably.
Our study has systematically addressed all 5 business questions. The analysis reveals 3 key takeaways. First, the dominant delay drivers are late arriving aircraft and carrier-related issues. Those are internal controllable factors, not external ones like weather or security. Second, delays follow clear temporal patterns, peaking in summer months like June and July, with a secondary peak in December, and mid-week delays slightly higher than other days. Third, flight distance has no meaningful correlation with delay severity. What truly matters is optional efficiency, how airlines manage turnaround, scheduling buffers, and congestion at busy airports. The core message is this: since most delays are internally driven, targeted operational improvements can yield measurable results. Data visualization through Power BI gives us the tools to identify these patterns and act on them with precision. That concludes our presentation on flight delay data analysis and visualization. We hope this study demonstrates how structured data-driven analysis can translate raw operational data into actionable insights for the aviation industry. On behalf of Group B No.6, I'd like to thank our lecturer for the guidance throughout this project.